Okay, so this was one way to do it with all of this kind of terrible, tedious algebra, but there is a much cooler way of doing all of this, and you may have been thinking this already over the last half an hour. And since we are essentially rotating points, why don't we use our knowledge of how to rotate vectors with rotational matrices, with transformational matrices. So recall from way back that remember what we're doing is we're looking for a matrix which will rotate theta degrees clockwise. And so there's some mysterious matrix which will rotate theta degrees counterclockwise, and the way we do this is we try to figure out what that matrix does to 1, 0 and what that matrix does to 0, 1. And we can draw a little picture to remind ourselves of this. Make sure this is in frame. Yeah. So if I have the point 1, 0 and it gets rotated theta degrees, then we end up here, and that point is by definition cosine theta sine theta, which means, so we can kind of draw sort of a circle, a unit circle, it's a terrible unit circle, and that means that this is cosine theta and this is sine theta. So it's cosine theta and that is sine theta. And so basically this matrix should do to 1, 0, it should make it cosine theta, it should make it the vector cosine theta sine theta, and what should this matrix do to 0, 1? Well, 0, 1 is going to end up here, and what is that point? Well, just by looking at this, you can kind of see that it's going to be that.
I'm heading out arrows.
So I see that too far. That is negative sine theta cosine theta. Just by kind of just like duh, by just looking at it. Or you could do some math that actually determines that also. Okay, so since that's true, and since that's pretty just like clear and intuitive, okay, so it does to the matrix 0, 1, it sends it to negative sine theta cosine theta. Okay, so you might just even like just remember that matrix, because it's only from like 2 months ago, and we used it kind of a lot, and you can almost kind of just regenerate it in your head by just like thinking. Well, using that matrix, now what we're going to do is the following logic, which is, you have to be sort of careful about this. And we're just going to kind of do it over and over again until it makes sense. So what is going on here? What's going on here is I have a point. And this point is x comma y, which means I go over x and up y to get to that point. Well, let's suppose that I don't know the x and y coordinates of that point. What I do know are the x prime, y prime coordinates. So I'm going to draw in the x prime and y prime axes, and basically, let's make this a little bit better. So I'm just going to make the angle kind of a little smaller. Okay, so what I'm looking for is, or what I know is that if I go over x prime and up y prime, then I get to that point. So this is x prime and this is y prime. In other words, I know the x prime, y prime coordinates of that point. This is theta, by the way. And what I want are the x and y coordinates of that point. Well, here is what I can do to get the x and y coordinates. I can go over x prime and, let's see, and up y prime. So let that be x prime and let that be y prime. So as you can see from the picture, if I know the x prime and y prime coordinates of a point, I can go over x prime along the x-axis and up y prime on the y-axis, and then if I rotate that point by theta degrees counterclockwise, then that brings me to this point xy. In other words, the x and y coordinates of that particular point, the xy vector, is what you get when you rotate the x prime y prime vector by theta degrees counterclockwise. I'll say that one more time. I know how far up I need to go along the x prime axis and how far up along the y prime axis I need to go to get to that point. So I plot x prime, y prime on the x and y axes, and then I rotate theta degrees. So this says that the x and y coordinate, how much I have to go over and how much I have to go up, is this vector rotated theta degrees. And then it just makes it really, really easy to write out what x is. X is just cosine theta x prime minus sine theta y prime, and y is sine theta x prime plus cosine theta y prime. And these two equations, you will notice, are the exact same things that we got over there with tedious algebra. But this time we have access to these equations like very simply. All you have to do is remember what it is you're trying to do and draw this little picture and just know this matrix, which is itself relatively intuitive. So we can skip all of these tedious polar geometric weird derivations, and we can just go to this picture every time I need this equation. Okay, and now, are you turning the thing for me? All right, thanks. And now we're ready to actually start our serious task. And our serious task is, I have an equation with a b term. So I have ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. My entire goal that started this entire lesson is make this b term go away. And I'm going to pause in a second. I don't know what I'm going to do. I want to make this b term go away. And how do I do that? The answer is I need to rotate. I need to rotate by some amount. So what I need to do right now is I need to figure out what the theta is such that when I rotate the axes, I will get a new equation which is expressed in terms of x prime. So b, x prime, y prime, c prime, because these are different, plus d prime, x prime, plus e prime, y prime, plus f prime. I need to figure out what the theta is such that this term dies. That's the whole point. Such that that term goes away. And then I can actually understand the conic. Okay, so what are we going to do, obviously, is I'm going to take my general conic and I'm going to use these formulas and I'm going to stick them in and I'm going to do an entire freaking whiteboard of algebra, and eventually I'm going to get some massive equation all in terms of x primes and y primes. And then I'm going to figure out precisely when does the b term disappear. And whatever combination of stuff makes the b term disappear, then that is going to tell me what angle I need to use. This lecture is going pretty well, I think. I think this is clear. All right. So let's basically do it. You can start without me. Take that equation, like I just said, write it out, and begin a massive, massive expansion. This is probably the most massive, tedious algebraic thing we do the entire year. It's great. It's really exciting. So, start without me, go. I think we should like put some music on in the background for this. No, is that gonna bother you?
No.
Okay, good. Because we're pretty much, function class, we're pretty much gonna do nothing but algebraic, tedious algebraic derivation for the next 15 minutes. Maybe that's an exaggeration, maybe it only takes like 10 minutes. My memory of it is that it's pretty long. Let's see, put something on. This is some good background music. Yeah, just entered.
So it doesn't matter.
Yeah, doesn't matter who's leaving. Not yet. Okay. This actually gets cut off, I assume. So let's move. Yeah. All right. Now we're just going to expand that whole freaking thing out. Start. D. That was C. Is it still in view? Yep. Probably making tons of mistakes, but hopefully not. Oh yeah, and then let's just finish it off, because I don't even really need D, so because those are pretty easy. Alright, so let's combine like terms now. So let's collect all the y, let's collect all the x prime terms. So I have so that is the coefficient of x prime squared. Yep. Plus, now I'll get the x prime y prime terms. Let's see. It's going to be that minus that. Well, I guess I'll just do it out. So it's that. So it's 2c. Cosine theta minus 2a. Prime y prime. Alright. Now we get the y prime squared term, just for the sake of actually doing it. And that is 8 squared theta. Soundtrack available on request. Yeah. And just to be complete about it, let's get the other terms. So that's plus, what x terms do I have? That's, I guess, d cosine theta plus e sine theta. X prime plus y prime terms are e cosine theta minus d sine theta, and then plus f equals 0. Okay, so we did this massive crazy thing, and here's what we've learned. I don't even know if you guys can see this at all. But what we've learned is that this giant thing, this is basically a prime, the coefficient of x prime squared. This whole thing here is b prime, the coefficient of the x prime y prime term. This whole thing is C prime, the new coefficient of the y prime squared term. This is D prime, this is E prime, and F just is F prime. Alright, so, alright, so what was the entire point of this entire thing? The entire point of this entire thing was to pick a theta such that the x prime y prime term disappears. Okay, so for what theta is that? Oh, I think something went wrong. Did something go wrong? I bet it did. I think there's like a B somewhere. Yeah, there's a B here. Plus B. Yeah, that's better. I have to pick a theta such that that x prime y prime term disappears. Okay, so that is what I'm going to do right now, and you could probably even like do this yourself, right? When is 2c sine theta cosine theta minus 2a sine theta cosine theta plus b cosine squared theta minus sine squared theta, when is that 0? When that b prime coefficient is 0, that means that we have no x prime y prime term, and thus we've picked the correct theta. Okay, well, there's some just like obvious trig identity stuff we can do here, right? This is just c sine 2 theta minus a sine 2 theta. And this is b cosine 2 theta. All right. So I can set up a little equation here. B cosine 2 theta is a sine 2 theta minus c sine 2 theta. In other words, b cosine 2 theta is a minus c sine 2 theta. And now we can write this as a tan function. So my final answer just about is that tan 2 theta is b over a minus c. And, there's a couple things to talk about here. First of all, if you take any conic, I should have mentioned this earlier maybe, if this is x and this is y, then like I don't need to be rotating that conic like, 200 degrees or whatever, right? Because if you're going to rotate it like 150 degrees, you might as well just rotate it like 60 degrees. Because, I hope that's obvious. So let's just say that my angle theta is always going to be somewhere between negative 90 and 90. Just by convention, let's say that I'm either going to rotate it back this amount or back this amount. I never have to go more than that. I hope that's just clear. Okay, well if theta is between negative 90 and 90, then at this point there are basically only two options. If a minus c is 0, then tan is undefined. Well, where is tan undefined? Tan is going to be undefined. I guess this is kind of a crappy way of doing it, come to think of it. Let's maybe just back it up a step. Then it's like we get less into like undefined crap. So let's say actually from this step, let's suppose that a minus c is 0. If a minus c is 0 here, then we really just have the equation, we have an equation that just says b cosine 2 theta is 0. In other words, cosine 2 theta is 0. In other words, 2 theta is, cosine is 0 at pi over 2. and so theta must be pi over 4. So anytime A equals C, then the correct angle to rotate is pi over 4. But if, on the other hand, if A minus C is not 0, then let's divide by A minus C. Yeah, this is the better way to do it. So then we get that tan 2 theta is B over A minus C. So 2 theta is arctan B over A minus C. And so our final answer, hopefully you can see that, our final answer is that theta is 1/2 arctan B over A minus C. In other words, given any giant terrible equation like we started with over there with a B term, by multiplying that all out and looking at what combination of A's and B's and thetas will make the x prime y prime term disappear, I've now determined that whenever theta is 1/2 arctan B over A minus C, then the coefficient B prime will be 0. I'm going to turn the music off now. Okay. So, I've learned so much. I've learned that I have to rotate my conics by 1/2 arctan B over A minus C, and the B prime term will disappear. All right. What I need you to do now, if you have not already done so, is I need you to download this packet from Edline. And we are now going to do an example problem. I guess actually you don't even really have to download this packet, I suppose. We're going to do 2 examples, and then this thing is going to be over. You probably don't even need to download the packet because the packet has nothing on it except a couple of equations. And basically there's one task now, and that one task is given a conic with an xy term, unrotate that conic, or I guess I should say rotate that conic, however you want to think about it, such that, create new axes such that there is no B prime term. Alright, let's do it. Here is the first equation. It is 13x squared plus 6 root 3 xy plus 7y squared minus 16 equals 0. By the way, we do not know that this is necessarily an ellipse. It could be anything. And what we need to do is to figure out how much to rotate this and perform a variable transformation such that then this conic will be perpendicular to some new axes. Okay, well, I use what I learned over the last half an hour, that theta is 1/2 arctan B over A minus C. Okay, well, I guess we just do it, right? So theta is 1/2 arctan, oh yeah, and try to maybe it's actually a good idea to pause it and try to stay a couple steps ahead of me. Try it yourself first, but we're just pretty much doing that together. So B over, just like you would in class, try to stay ahead of me. So B over A minus C, so I guess that's 6 root 3 over 6. So that's just arctan root 3, that's pi over 3, this is just pi over 6. Okay, so the first example is a nice one. I have learned that theta is just pi over 6. That's how much I need to rotate this conic to make new axes x prime and y prime. Alright, and then personally, all those formulas from the first hour of this video, I do not memorize them. I rederive them every time. And I rederive them using this exact same logic that I was talking about before. So I'm just going to go through all the logic all over again, and because I think it's a little tricky, and on the third or fourth time you do it, then it suddenly seems normal. So I have my axes. This is my x-axis, this is my y-axis, this is my x prime axis, this is my y prime axis, and we have rotated theta degrees. And here is the logic. The logic says, pick a point over here, and I would like to know what the x and y coordinates are of that point. In other words, I'd like to know how much I have to go over and how much I have to go up. I already know what the x prime and y prime coordinates are of that point. So that's x prime and that's y prime. I know how much I have to go over along the x prime axis and how much I have to go up along the y prime axis. And so what I do is I plot the point x prime comma y prime. I plot the point x prime comma y prime with respect to the x and y axes. So that's x prime and that's y prime. And I say, okay, if I plot this point, x prime comma y prime, or even, like a vector basically, and then I rotate that vector by theta degrees, then I get the new point x comma y. In other words, this whole picture, which I really do redraw every single time, is just to remind me that the x and y coordinates of this point I'm interested in are what I get when I take the points x prime and y prime and rotate them by theta degrees counterclockwise. Cosine theta sine theta, negative sine theta, cosine theta. Say it one more time. I go over x prime and up y prime, and I rotate theta degrees, and that brings me to this point, and it gives me the x comma y coordinates of that point. I think it is kind of tricky, but hopefully this explanation is working for you. Alright, so this just enables me to quickly rederive the formulas minus sine theta y